The CRISPR-Cas9 system is a tool for cutting and modifying DNA. This technology has already revolutionized gene editing, as well as opened a whole new world of possibilities for scientists. But before we dive into how scientists use CRISPR, we need to understand how bacteria use it naturally. CRISPR is naturally found in bacterium. CRISPR along with the Cas9 protein are used in bacterium as an immune defense. How does this work? Well, when a virus attempts to invade a bacterium, protein Cas9 cuts a part of the viral DNA and stores it in the CRISPR DNA section, creating a quote-unquote snapshot of the infection. CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats. The CRISPR section of DNA in bacterium are repeating sequences of DNA. The snapshot of DNA is copied into short RNA fragments. Those fragments bind to the Cas9 protein. The combo scouts for free-floating genetic material and searches for a match to the virus. If the virus ever invades again, the Cas9 protein swiftly attacks and destroys the viral DNA. Scientists found out how to modify this protein not to only target viral DNA, but almost any DNA. This leads us into how humans have learned to manipulate this process to possibly cure the genetic disease. Dr. Doudna and Dr. Charpentier were the two scientists that researched and learned how to modify CRISPR. CRISPR allows scientists to rewrite DNA in a cell. Modified CRISPR consists of two components, the Cas9 protein, which is the cutting tool, and the guide RNA, which locates the sequence of DNA to be edited. But how biologically does CRISPR work? First, scientists pinpoint the sequence of DNA that is causing a health problem. For example, sickle cell anemia or osteoporosis. The second thing is that they create a distinct guide RNA strand that opposes the sequence that is causing the problem. The guide RNA is then attached to the Cas9 protein and is inserted into the cell. Guide RNA finds the sequence and Cas9 cuts it. From there, scientists can modify it how they like, by deleting or inserting new DNA. If you want to learn more about CRISPR, I've linked some videos and resources down below. A huge thank you to the Stop Motion app. It's the app that I use to create all the stop motions shown in this video. This will also be linked in the description below. Well, thank you so much for watching, and I hope you learned something.